rectilinear motion. It's just another way of saying we're going to talk about position functions, velocity, and acceleration. A particle moves in a straight line and has acceleration given by 6t plus 4. You know its initial velocity, its initial displacement. We want to find the position function. Well, we can do that. It's the exact same thing as what we just did with number 26 here, because acceleration is the second derivative of the position function. So my acceleration is equal to 6t plus 4. That means my general function for velocity would be add 1, divide, plus a constant. I also know that the initial velocity is negative 6 centimeters per second. So v of 0, and I like to go ahead and simplify stuff now. So 3 times 0 squared plus 4 times 0 plus c is equal to negative 6. I think you can tell that c is negative 6. So my velocity function is 3t squared plus 4t minus 6. Position function is the antiderivative of velocity. Add, divide, add, divide, give that a t, and add a constant. I know that s of 0 is equal to 9 centimeters. That cancels with that. I have 0 cubed. 2 goes into 4 twice. Equals 9. So my position function in all its glory, t cubed plus 2t squared minus 6t plus 9. And there be the pretty answer. Okay, let's look at an application problem. A stone is dropped from the upper observation deck of the CN Tower 450 meters above the ground. There's their obsession with the CN Tower again. So that means its initial position is 650 meters. We want to find the distance the stone is above the ground at time t. So my goal, s of 0 is 650. My goal is s of t. And they don't give me anything else. But luckily, I happen to know acceleration due to gravity is 9.8 meters per second squared. So that means that velocity at time t is negative 9.8 t plus a constant. Well, they don't tell me what the initial velocity is. But wait, it's dropped. If you drop something, what's the initial velocity? 0. You don't throw it down, you just drop it. So initial velocity is equal to 0. That means my c is going to be equal to 0. Because negative 9.8 times nothing plus c is equal to nothing. So v of t is just 9.8t. So now we want our position function. Add 1 to the exponent, divide by the new exponent, and there was no c there, but we add yet a different c. So this is a different c than that c. That c was already 0. But I have an initial condition for my position, negative 9.8 divided by 2. Yeah, I know I should be able to do it in my head. I think it's 4.9. Yeah, it is 4.9. Yay me. Times 0 squared plus a constant is equal to 650. So minus 4.9 t squared plus 650 is my position function. Now we can answer all the other questions. How long does it take the stone to reach the ground? Now that we have a position function, we can figure that out. We just said its position equal to 0. So negative 4.9 t squared is negative 650. So t squared is 650 over 4.9. So t is plus or minus the square root. And I know it's not minus because I don't have a time machine. Let's plug that in the old calculator and get a real life number out, because I have no idea how long it takes to get 650 divided by 4.9 under a square root seconds. .52 seconds. Now I know how long it takes to hit the ground. I can find the velocity when it strikes the ground. I just find the velocity after 11.52 seconds. So I just need to take this. My velocity is negative 9.8. So times negative 9.8 gives me minus 112.87 meters per second. Don't forget your units, because velocity is useless without units. This was seconds, because t is time. Time was measured in seconds. If the stone was thrown downward at a speed of 5 meters per second, how long does it take to reach the ground? So I'm going to let you figure that out, and then we'll come back and compare. Okay, I finally heard you. It was 450, not 650. I went back and fixed it. I hope it didn't keep you from understanding what we were doing, because I wrote that down wrong. So the initial position was 450. I was trying to make the CN tower taller than it is. So my constant when I got here should be 450. That should be 450. So that should be negative 450. And it's 9.58 seconds. And then I plug 9.58 in for the velocity. I did it in the calculator, so the right answer is there now. So this is 9.58. 9.58. So negative 93.91 meters per second. Okay. Then we come over here. We have a new velocity, initial velocity, which gives us a whole new velocity function, which gives us a whole new position function. And this was a job for PolySolve. I get two potential answers, 9.08 and negative 10.10. I choose the positive one because I cannot go back in time. Alrighty. Yeah. 2 more examples. Example 7. This time we have a ball thrown upward with a speed of 48 feet per second from the edge of a cliff that is 432 feet above the ground. Find its height above the ground t seconds later. When does it reach its maximum height and when does it hit the ground? All righty. I had to check and make sure what acceleration due to gravity was in feet per second. I have meters per second memorized. Feet per second, I wasn't sure, but I was right. It's negative 32 feet per second squared. So acceleration due to gravity is negative 32 feet per square second. Okay, it's thrown upward at a speed of 48 feet per second. So that's my initial velocity is positive 48 feet per second. And we're at the edge of a cliff that is 432 feet above the ground. So my initial position is 432 feet. Okay. So we have to work our way backwards. We go from acceleration to velocity. Just t, not t squared. Getting ahead of myself. 32t plus a constant. And my velocity at time 0 is negative 32 times 0 plus c has to be equal to 48. So my position function is negative 32, add 1 to the exponent, divide by the new exponent. 48 gets to have a t, and we have a constant. And we have an initial position, 432 has to be equal to negative 16 times 0 squared, because 2 goes into 32 16 times. 48 times 0 plus c, so my constant is 432. Negative 16t squared plus 48t plus 432. And then we're asked some questions. We want to find its height above the ground at t seconds later. Well, that's the answer to the first question. That's the height above the ground t seconds later. When does it reach its maximum height? How do we find maximums? Well, this is actually one you could have done back in pre-calc, but I'm not going to use that. I'm going to take the derivative. 2 falls down and set it equal to 0. And that I can solve. I don't need a polysolve button for this one. 48 divided by 32. So it's going to reach its maximum. 32t equals 48 after 1.5 seconds. And let's see, does it ask its height? No, it just says when does it reach its maximum height. If you wanted to know what the maximum height was, you could just plug it in. Negative 16 times 1.5 squared plus 48 times 1.5 plus 432. Its maximum height S of 1.5 is 468 feet. Then it starts falling down. And when does it hit the ground? It hits the ground when S of t is equal to 0. That, my friends, is a job for the polysolve button. So negative 16, clear out the old stuff, 48, and 432. I get two answers, t equals negative 3.91 or t equals 6.91. You have all the knowledge that you need for your WebAssigns.